Alright, now, if you look at the second question right here, it says that we need to fill in the numbers 1 to 9 into each of the 9 circles in the graph, and then show that the sum of the 3 numbers on each side of the triangle ABC and the triangle DEF is equal to 18. So how many ways are there for us to fill in the circles? Well, you can see that I have 1, 2, 3, 4, 5, 6 sums altogether, right? So it's 6 totals altogether. And then you can see that these 3 boxes are counted twice, where these 3 boxes in blue are counted 3 times, and these 3 boxes in green are counted once. So in other words, it means that if I'm naming them A, B, C, D, E, F, G, H, and I, A, B, C are counted twice, D, E, F are counted 3 times, G, H, I are counted once each. So it means that it's equal to 1 adding all the way to 9, adding A, adding B, adding C, adding 2 times D, adding 2 times E, adding 2 times F. But then that's gonna be a bit troublesome for us to calculate it this way, because I don't have some identical coefficients that I can analyze on. So if I want to find out a different number of ways to fill in the circles, that's going to be slightly more complicated. Because you can see that GHI, DEF, and ABC are like 3 groups, which are counted 1, 2, and 3 times. So there's a gradient in there. But then there's something we can do which can change the situation immediately, which is if I'm counting 1 to 9 twice each, it means that I would have been counted A, B, C the exact number of times as it is in the diagram, but GHI 1 time more and DEF 1 time less. So I need to add DEF there and take away GH and I, right? So how does that help? Because we know that the sum is equal to 18 on each line, right? So T is equal to 18, and that's going to be 108. So 108 is equal to 1 adding to 9, that's 45, times 2, which is 90. Adding DEF, take away GHI, which means that 18 is equal to D adding E adding F, take away G, take away H, take away I. So if you're looking at the numbers 1 to 9, you can see that the only possibility that 3 numbers are 18 larger than the other 3 is 7, 8, 9, take away 1, 2, 3, which sums up to 24 and 6. So the largest 3 take away the smallest 3. And of course, if I am arranging 7, 8, and 9 in a triangle, well, if we don't consider the arrangement, there's only one way that we can do it, right? So it's either clockwise or anti-clockwise, but there's just one way for us to do it if we don't consider the arrangements, because there's going to be a common edge between 7 and 8, 7 and 9, and 8 and 9. So 1 each. And then for the smallest side, of course, I have 3 there to make 18, and then 1 there for the largest side, 2 there. So for the remaining numbers, of course, that's also going to be pretty easy for us to fill in, because I have 4, 5, and 6 left, which I know that 4 and 6 is going to make a 10 together with 8. That's going to be 18. And that's going to be a 5 there to complete this triangle. So it means that if I don't consider arrangement, there's just going to be one way of doing it. However, there can be different arrangements for the positions of 7, 8, and 9. First of all, we can have 7, 8, 9, 7, 9, 8, and then we can have 8, 7, 9, 8, 9, 7. And then finally, we can have 9, 7, 8 and 9, 8, 7, right? So there will be 6 different arrangements. So there will be 6 ways that we can fill in the circles, all right? So that's what we can do for this question.